in this video we're going to talk about x and y intercepts of a function, what that means and how to find them. X and y intercepts can often be a little confusing to students, so we want to make sure that we clarify that as much as possible. So the idea behind these is pretty straightforward and pretty simple, especially when we talk about what the word intercepts mean. And a lot of students associate the word intercept with interception, which really just means to meet. So we're taking a look at where the function itself is meeting either the x-axis or the y-axis, and that's what's describing our y-intercept and our x-intercepts for us. So if we take a look at a graph, it can be pretty easy to identify where those are. So if we want to take a look first, maybe we'll take a look at the x-intercepts first. So if we take a look at the x-intercepts first, that's going to be where our function hits the x-axis. And in this case, this one resembles a cubic function. So this resembles a cubic function. It looks like in this case we have three x-intercepts, and those are going to be three separate values that we are going to write down in terms of that. So for our x-intercepts of this function, x-intercepts, okay, we can write those down, and sometimes they're written down as values. So sometimes we might say x is equal to, in this case, 0 is one of those. We might say positive 1, 2, 3, 4, 5, maybe 5.5 if we were to estimate that, so 5.5. And then for our last one, we might estimate it as 1, 2, 3, 4, 5, 6, maybe 6.3. So maybe negative 6.3. Now, of course, I didn't do that very accurately, but for the purposes of this video, we're just looking to identify those at the moment. Now, so this is one way that we might list those, but another way that we might list those, just to be a little bit more explicit that they are x-intercepts, is as the points themselves. So one of those points, if I were to take a look at the x-intercept of 0, then we would actually describe that as having an x value of 0 and a y value of 0. So that describes this point right in the center of our graph, the origin. Then our second point, we might describe that as the point 5.5 comma 0. Now I want you to notice something. If we take a look at the y value of each one of those, the y value is 0 for both of those. So the y value is 0. And that makes sense because if we were to take a look at any point that's on the x-axis, then it's going to have a y value of 0. Every point on that x-axis is going to have a y value of 0. And then our last one, we might describe this as negative 6.3 comma 0 in a very similar way that we did to the other two that are there. Now for y-intercepts are done in a very similar way. We can take a look at the y-intercepts in terms of where it's hitting the y-axis. And for any function, anything that's described as a function, this should actually only happen one time. And that goes back to the definition of what it means to be a function, in that for every x value has exactly one y value that it goes to. So for the x value of 0, which in this case describes anything on the y-axis, our x value of 0 is only going to have one value associated with that. So we might describe the y-intercept as a y value equal to 0, or we might say a y value to 0 here, or we might consider the point that it is there, which is the point 0, comma 0, okay, 0, comma 0, which describes the y-intercept because it also has an x value of 0. So a y-intercept is always going to have an x value of 0, and an x-intercept is always going to have a y value of 0. And this is hugely important. I can't stress this enough. These two little concepts here come into play in almost every aspect of Algebra 2. So it's really, really important to understand exactly what those mean. An x-intercept as a y value of 0 and a y-intercept as an x value of 0. And just to demonstrate that point, we can find the x and the y-intercepts of an equation. So let's take a look at the equation here. F of x equals 2x plus 3. And we'll see if we can find the x and the y-intercepts of that function. So just like we kind of described before, the x values and with the x-intercepts and the y-intercepts, for an x-intercept, we're looking at where the y value is 0. Now, since this is in function notation, that means we're taking a look at where f of x is equal to 0. So we can set that equation equal to 0, And we're going to take a look at 0 equals 2x plus 3. And if we solve that for x, that's going to describe what our x-intercept is. So if we subtract 3 from both sides, we get negative 3 is equal to 2x. And if we divide both sides by 2, we get an x value that is equal to negative 3 halves. And that actually describes our x-intercept. And the reason why is because we set the y value, the f of x value, equal to 0. So this describes the point negative 3 halves, comma, 0 as an x-intercept. So that would be one x-intercept. And since this is a linear equation, we would expect it to only have one x-intercept. Now if we're taking a look at a y-intercept in a very similar way, our y-intercept, we know that a y-intercept is going to be where x values are 0. And so if we substitute in for x into our function, we substitute in 0 for x. And so just to give you an idea of what that looks like, we're looking at the f of 0 value that describes plugging in 0 for x, 0 in place of x here, is equal to 2 times 0 plus 3. Now 2 times 0 is of course 0, and if we add 3 to that, we get f of 0 is equal to 3, which describes the point. We have an x value of 0, we substitute that in, and a y value of 3, and that was our derived point. That's what we got when we substituted in 0 for x. And so that's describing our y-intercept of this function. And now if we wanted to, we could look to then graph this function just based upon the intercepts that it has. So for a y-intercept of 0, 3, we know that that point is right here. And then if we take a look at the x-intercept of negative 3 halves, 0, negative 3 halves is negative 1.5. That's this point right here, and comma 0. So that's going to be right on that axis. And then we can look to draw up a line between those. And I'll just draw a quick line just so that we can see what that might look like. And once we draw our line, then we can certainly see that those are our intercepts. Of course, it matches what it is that we just found in terms of our derived equation. And if we take a look at the function itself, the f of x equals 2x plus 3 is a linear function. It also matches what's here. We have a y-intercept of positive 3, and then we have a slope of 2, which is described as part of that function.